Hey folks, welcome to the next episode, or maybe this is going to be a series of episodes on matrices and determinants. And this is what I call as crash course, which is a compilation of all the flashcards and everything in a condensed format. You don't have to go through any textbook, exactly sized for the examination. And just as a quick preamble, who should refer this? Any audience, or if the learning objectives is just to clear a paper, you're not really worried about learning, understanding the concepts and stuff like that. Your job is to just clear your paper, get it over the hump, get the bare minimum, or whatever your goal is. You should go through these episodes along with the examination problems. The content has been, at least the content from the solved problems has been prepared strictly for the Maharashtra State Board Paper Code 22103 First Year Basic Mathematics. However, the content is still generalized for all the Polytechnic students pan-India, or even grade 11 and grade 12, wherever you have the syllabus. With the combination of this and all other detailed episodes that I put, you can still get a good perspective and learning on the subject of matrices and determinants. The pattern is going to be all this content, which is going to be a series of episodes till I cover the syllabus for this particular branch. Is going to be small bite-sized episodes, 5 minutes, 6 minutes, so that you can easily remember few days or one day before the exam and apply the concepts. And this is going to not have any intuition on why and what, where did it come from. It's just going to focus on how should you remember the formula, help you memorize it, help you rot it, however you want to call it. So no extra toppings, no bells, whistles. This is going to be straight up. The focus is going to be just focusing on your exam and clearing the paper. And if you're interested to know more about any of the topics, check out all the other episodes where I've detailed about the intuition and perspective on how to think about that, where did the formula come from, and so on and so forth. This is, like I said, this is going to be for the last minute study folks, which is what all of us, including me, like to do, one day before, one night before, 2 weeks, wherever you are in the study spectrum. Okay, without further ado, let's dive in. Okay, so what are matrices? Okay, what is the definition of matrices? And since we're going to cover both matrices and determinants, in the Polytechnic textbooks, usually they cover determinants first and matrices, but both the topics are kind of interleaved. So I've combined everything in the right sequence so that you understand where are we coming from and how should you understand the concept. Okay, so let's start with the matrices, and you will see some portions of determinants, and then again we get into matrices. So what is a simple definition of a matrix or matrices, or in the Western country they call matrices? If you go to the Wikipedia, the simple definition is matrices, and actually even determinants, are nothing but a bunch of numbers which are arranged in the form of an array, like this or any form. They are just arranged in the form of array, and they represent something. They give meaning to something for which we're trying to solve the problem, which we will be seeing in the further videos. And it can be numbers. If the given problem contains numbers, it could be, the array could just mean that. Or if the given problem could contain objects, like for example this clock, and you want to represent this clock in the form of a matrix, typically in visual graphics or computer graphics, that's how you're going to codify, because the computer graphics will not understand what the clock is, whether you want to increase this clock size, decrease this clock size, or move it somewhere else, how it's going to understand. So what the computer really cares is, what are the coordinates? It understands everything in form of coordinate, whether if it's a two-dimensional, what are the coordinates for these two, x and y, and what are the coordinates for this point, which is x and y, and you just pass it in a matrix format, and whatever operation you want to do, it will do it for you. Similarly, for this picture of Mona Lisa, let's say you want to morph it, you want to reduce it, increase it, or you want to do anything, you want to make this Mona Lisa, put it on Instagram and do something fancy. How do you do that? How does the computer understand what are you doing? So basically you just pass the coordinates of the 2 points. If you see here, this point or this point, and it will kind of apply that for the whole picture. So it's more of a coordinate passing. So matrices in essence are a rectangular array or table of numbers which could represent the numbers itself or any of the object that you want it to be represented in a condensed format, so that the computer understands this very well. Similarly, for a vector, the computer does not really care about what is a vector and all those things. The computer just wants, okay, if this is a line, this line has a magnitude and this line has a direction. That's definition of a vector, magnitude and direction. Okay, so as long as I tell it the magnitude and direction in terms of x and y coordinates and condense it either like this or like this, doesn't matter, any condensed format within this notation, that becomes a matrix. You arrange the numbers to represent that. Okay, that's what a matrix is all about. And in terms of denotation, or notation, sorry, all the matrices are always expressed in capital letters. Typically, you'll see A or M, which the matrix calls A, M, B, X are the typical words, but you can use any alphabet but express in capital letters. And other thing is, the array will be always boxed inside the square brackets. That's a typical. That's what differentiates matrices and determinants, or even in fact in regular computer array where you don't see this kind of format. So when you see this kind of a bracket which is square in nature, that means the numbers within those two brackets, opening and closing, are nothing but they are denoting a matrix notation of something. That's kind of the notation part of that. And how do you know what are the other terms, or what are the bare minimum terms you need to know about matrices? There's something called as order of the matrix, which is nothing but it tells the matrix within the array how many rows and how many columns the matrix has. For example, if you see this, anything that is in the X direction is a row. Okay, this is a row. And anything that is in a Y direction of the axis is column. So if you see there are two rows here, row 1, this is one row and this other row. So this matrix has two rows, or you can also call it the dimensions, but order is kind of the word that is generally associated with the matrix. So the order of this matrix is two rows. And how many columns? There are 4 columns on the which are parallel to the y-axis. If you count it vertically lines up, there are 4 columns. That's what it means. So when you say the order of the matrix is 2 by 4, it's not a multiplication. It's a way of denoting it, but it means the order is 2 by 4. So you say 2 by 4. That means this matrix has 2 columns. And this matrix has 2 rows and 4 columns. That's what it means. Similarly, if you see, I put another examples. I've just copied a lot of images from Google to give you a perspective. This matrix also has 2 rows. I put some real numbers and 3 columns. And if you see this matrix B, like I said, it's expressed in capital over here. Again has 2 rows and 3 columns. And if you go to the higher order where this is like just in X and Y, but if you want to do X, Y, and Z in 3-dimensional, this is how you get. Again, you can put it in X and Y format, but this is also a common denotation on how you should use it. And the way you read it is all the variables where you see this subscripts, which are in numbers. The first number denotes the number of the row where the element is. All these things are called elements. So this matrix has got 9 elements. And this matrix has got 1, 2, 3, 4, 8 elements, like that. So for each of the element, instead of using this representation of order of the matrix, you can also denote by numbers where you have I and J, where I means what is the row of the element, and J means what column the element is. You can represent that way also. If you see all of this over here is first row. That's the reason if you see the first subscript, the number is always 1, 1, 1. But if it's the second subscript, it's a column. So this first column, this second column, and this third column, and so on and so forth. So anything that is in the y-axis, you can count as columns. Anything that is x-axis is rows, and you always write the rows first and by the columns. That's how the matrix notation is. You can either use this format for order, or you can, in some examples, you'll also see, and you'll see where it comes handy in terms of what element you're talking about. Because here you cannot say, I want to talk about row 1 and column 5 and all those things. You can just say, I'm talking about A to 2, which in turn the computer will understand, okay, it's talking about an element that's in second row and second column. So that's what the concept is, order of a matrix. So far in this episode, we understood what is a matrix all about and what is the order of the matrix. So we'll wrap up on this one, and we'll go to the next byte episode on types of matrices.